The next problem is called transshipment problem. But before we get to transshipment problem, I want to set up this transportation problem in a slightly different way. And it may seem kind of more complicated than how we did it the first time, but the the different way in which we're going to set this problem up will make it easier for transshipment problem and other network problems. Okay, so we're going to do the same thing, the first problem that we solved, the transportation problem with Des Moines, Evansville, Fort Lauderdale as the three supplies, and Albuquerque, Boston, and Cleveland as the three demand destinations, and the supply and the demand are in balance. Okay, so that's sheet 5. So we'll enter the values, the cost of shipment, and the supplies and the demand values. We'll enter it into this area. Okay, so these are the costs. Okay, and these are input, and okay. Now we need to set up a table of all the arcs possible. Okay, so here let me copy paste this into 5, and you see there is an arc going from each of the sources to each of the destinations. So we'll call these origins and these as destinations, and we'll number them. So origin 1 will be Des Moines, origin 2 is Evansville, origin 3 is Fort Lauderdale, and similarly destination 1 Albuquerque, 2 Boston, and 3 Cleveland. So we have now arcs going from 1 to 1, 2, and 3, right? So from 1 to 1, 2, and 3. Then from 2 also to 1, 2, and 3, and from 3 to 1, 2, and 3. Okay. So now we're going to have to set up the shipping cost. So what is the shipping cost going from 1 to 1? That will be that. 1 to 2, that will be that. We don't want to go and do this individually, so we should be able to set up a formula, one formula, okay, and then we should be able to copy that formula all the way down, which will transfer these shipping costs down here. And for that, we're going to use a function called index. Okay. Now, index has 3 arguments. The first argument, okay, is the lookup array. So we want to look up the shipping costs in this array or in this range, lookup range, right? Then the next item is row number. Which row should I look at? Okay, so now that's going to be the origin, right? So origin is the row, and next is column, destination is the column. Okay, now there is one thing we forgot, which is for us to be able to copy, and when we copy, the origin and destination will change, but the lookup range must stay the same, so that must be absolute referenced. So now what this is going to do is in this range, it's going to look at origin row 1, column 1. So that will be Des Moines to Albuquerque. When you copy it down, so it will be row 1, column 2. So it will be Boston. Okay, so now we have the costs, and we're going to look at what should be the flow from origin to destination. Okay, which means how much is the transportation going to be in each of these arcs. That's what our changing cells is. Okay. Now we need to make sure that these flows do not, these flows are within the limits of the supply nodes and they satisfy the demand of the destination nodes. So we have the capacities here, which is that going this way. Okay, and the demand, so demand is in a row, so there are 3 demands, so I have to use transpose the array function. We have done transpose before, so close parenthesis, and since this is an array function I have to press Control Shift and then enter. Okay, remember, for the transport to work you have to first highlight a range of cells that's exactly of the same size as the source and then type the function. Okay. Now let's look at the supplies. There is 1, 2 and 3 and 1, 2 and 3 for destination. So the region here is destination, or we could say 2. This is from. This is origin, this is destination. Okay, let's call it destination. All right. So now the functions that the function that we're going to use to figure out how much gets shipped out of origin. Okay, so we're going to use a function called SUMIF that will sum this column. Okay, whenever origin is equal to 1 here, origin equal to 2 and origin equal to 3, and that is called SUMIF. Okay, SUMIF. So first we have to set up the range for the if condition. Okay, so the if condition is, okay, this is supply, so it's origin. Okay, and we have to make that absolute reference. Is the origin equal to that? Okay, then sum that part. Okay, again that should be absolute referenced. Okay, so what this will do, it will go through this column, and wherever there is a number that equals that, then it will go ahead and sum the corresponding flow values. So that will give us how much is getting shipped out of the origin. Right? So now if you copy that down, so this will give you, this will filter the flow with origin equal to 2. So it will filter it down to just these 3 cells and sum those. And here it will filter the flow for these 3 rows. So it will be these 3 cells and add them up. And so that will be the amount of transportation going out of those nodes, and that should be less than or equal to capacity. Okay, so that is outflow. Now inflow coming into the destination, again it is the same kind of function, SUMIF. Now the first thing is the if condition range. Now this time we have to use the destination. So coming into destination, so again press F4 and the destination number, right? And then what should be summed, which is this flow. Okay. Press F4 again. Okay, so that should be equal to demand. Okay, let's center that. Okay. Now setting up in this fashion is obviously more complicated than how we did it here. But believe me that this makes transshipment problems and other network problems a lot easier to set up. That's the reason why we need to understand how to do this in this fashion. If it is just a transportation problem, then okay, this would be definitely more straightforward to set up. Okay, so now we have the constraint set up, now the cost. So cost will be some product of the shipping cost per unit and what actual flows have taken place. Okay, so that will give us the shipping cost, and we will do currency there, and that's a objective function. So now we are ready to solve. Okay, so total cost, minimize, changing cells is the flow, and the constraints are the outflow from source should be less than or equal to the capacities, and the inflows into the destination points must be equal to demand. Okay, non-negative, simplex LP, solve, you get exactly the same answer like here. So this is formulation as a flow problem.